So thank you all for coming. I'm using this for the people on Zoom, but it's not, so I don't, it's, anyway, my name is Ned Reifenstein. I am a AIA East Bay board member along with Shivani Bala. We are co-leading the revived coach group here in the AIA East Bay. It's been moribund for a few years and we're trying to get it restarted. So before I introduce the speakers, I want to encourage people who are interested in joining us in the future to send us your contact info. And our next session will be at the end of November, where we want to really make it more of a planning session and really talk about how we can move the group forward in the new year, what kinds of events, programming, conversations we want to have. So please join us. And and also there's going to be a survey in the next few weeks that will be going out more generally. Please tell us what's on your mind. This is your committee. So now tonight we have two great speakers, Jack and Larry. Jack Rusk is the, I have to get it right, Director of Climate Strategy at EHDD. He has a great origin story, which you should ask him about how he got there and how he ended up in that position. He is leading the development of the EPIC tool, and I won't pretend to know what that stands for, but it's a great calculator for thinking about embodied carbon in the built environment. Larry Strain is a founder and principal at Siegel and Strain, one of the leading community-based and sustainability offices in the East Bay. He has been a leader for many years, and particularly around carbon and the message of reuse of the existing building stock as being an important way to deal with embodied carbon in the built environment. So without further ado, I'm going to leave it to Jack to get started. Thank you.
Me? All right. We're going to do a brief, I think we have an hour and a half. I'll do a kind of 10 to 15 minute level set, get me with speed on carbon, why it matters, review for some, new for others, but a nice kind of common language. We can all talk in. Larry will, because the first question you should always ask is, should we build a new building or reuse an existing one? Larry will go first, presenting the tool. I'm going first. And then I'll come back with EPIC at the end. We'll weave back and forth, and it'll all go very smoothly. It's nice. I'm at EHDD in San Francisco, obviously, but it's really nice to be here. I live just a couple blocks from here, so it's nice to be my home turf. Okay, this is a statistic that you've probably heard at the opening slide of many presentations, that buildings and the built environment is responsible for 39% of global emissions. And I'm going to sort of like try to break that down and recontextualize it to the building scale. First, obviously, energy-related emissions, the stuff it takes to heat, cool, condition the space, and ventilate buildings is about 28% of global emissions, which is staggering. And then all the emissions from industry, cement, steel, chemicals, right? All the fossil fuels that get turned into plastics, and in buildings, aluminum. That's about 11% of global emissions that go into the built environment. There's another statistic that in around 2020, an academic paper showed that more concrete had been produced in the 20th century than the mass of all living things on Earth, right? We reached an inflection point, a tipping point between those two. There's just a massive amount of stuff that forms buildings and infrastructures, and a really fantastic climate contribution related to them. So some of those, the embodied emissions, right, is the building materials, all the stuff that goes into a building, and the other 3/4, right, the 28% of the 40% is energy use that comes from sometimes fossil fuel used on site, but often energy up in the nether regions in the Central Valley, or in big natural gas plants hidden away in things that look like buildings around the Bay Area. So a little out of sight, out of mind, but a really large contributor to emissions associated with buildings operation. So we'll get back to this and we'll try to break that down. I want to use this to show that over the course of, say, a building that'll exist from sort of now until 2050, the building in this time will have approximately the same proportion of emissions. Depends on where you are. We'll get into all that. It depends in a little bit. But there's a little bit of operational emissions that build up year over year, a big surge of embodied emissions in year one that persist. And we see that over the course of, between now and 2050, about 3/4 of emissions come from operational energy, like the energy used in buildings. And this is why for a long time, the 2030 commitment, all of these efforts have been to reduce energy use in buildings and to electrify the buildings so that you're no longer burning fossil fuels on site. Because when you have an all-electric building on a clean grid, you see that the line starts to curve down. The delta, the additional emissions in each year gets smaller year over year as the grid gets cleaner. You're using the same amount of electricity from a cleaner source upstream. There's less emissions associated. And the real thing that has been like, we're going to electrify buildings and we're going to make them more efficient. And then you're able to get to a situation like this, which is really exciting to see. So not only is the grid getting cleaner in the background, but you're using less energy each year. And then we see, question.
Is there a controversy going on right now about where the embedded or where the functional energy is coming from? Those sources are themselves destructive.
Yeah, we can talk some about that when we get into maybe what embodied emission looks like for things like PV. It doesn't always
When questions come from the audience,
repeat them in the microphone. So the question was, well, wait a minute, don't all these upstream clean energy solutions have impacts of their own that aren't always accounted for? This may be an interpretation of that question.
sure.
And I think one thing to point out there that is often lost, and we can get, this is a conversation over drinks we can have as well, but one of the easy answers is that, yes, there are upstream impacts, and we mustn't forget that not only is fossil fuel generally the thing we burn in our gas tanks, it's refined up in Richmond, but it's also an extractive industry with massive, right? Like the amount of land that's contaminated, all the water that comes up with the oil then is cast over fields, and like there's all this salt and minerals and heavy metals in that. So I think in an apples to apples comparison, we shouldn't discount the environmental impacts of clean energy. And let's also recognize that it's not just burning fossil fuels as the problem, but it's also the landscapes across which they're extracted. Does that make sense?
Yeah, I'm also thinking about, for instance, solar panels.
Absolutely.
That the destructiveness of making solar panels and then using them over a lifespan is a huge garbage result, as well as the making of the panel requires huge amounts of hydrochloric acid, which is something that's never talked about. And
I think it is like
destructive.
the question comes, there's a lot of hydrochloric acid used in solar panel manufacture. And I think the thing that's always important to do in this conversation is never to discount the real environmental impacts of anything. Building a building is actually a pretty ugly fact sometimes in the world, right? We shouldn't shy away from these real impacts that exist and take every opportunity we can to make real kind of comparisons about how to do better. I think a lot of Larry's talk will speak to this really well, that actually one of the clearest things we can do in all these circumstances is not to use new materials, but to reuse what we already have. We can make, things a little bit better. Insulation, again, like can be a kind of like nasty material. We can use better insulation, but what does it also mean just to use the stuff that's already there, displacing these sort of impacts that are in some sense unavoidable by participating in these supply chains. Other opportunities also exist, like bio-based materials. But I think the kind of frame here a little bit is that environmental impacts of providing shelter, healthy spaces for us to live and work and like thrive in has environmental impacts. And how do we make sure we're taking that seriously, like it seems like you are, and the day-to-day decisions we're making as like architects and engineers. So when we combine electrification on a clean grid with energy efficiency, we get to something that looks like this, where in 2050, looks like we're doing pretty good. This is a little bit more than a 50% reduction in emissions, right, over this time. And if we're going to get to, these big reductions by 2050, we're doing a pretty good job overall here. The problem, though, that emerges is that we don't just care about emissions in 2050. If we cut the same graph in 2030, we see that actually most emissions between now and 2030 are near-term climate targets, are mostly embodied carbon emissions, the stuff involved in the supply chains of the materials coming to the building. These are some of the things you referred to, like all of the environmental impacts of, you know, like the things that create the solar panels, the cladding, the insulation, the carpet, the, you know, the gypsum wallboard. These are most of the emissions that the built environment will incur in the near term that we need to address to meet short-term climate targets. The 2030 target is generally important because hitting a lower carbon overall emissions globally by 2030 will help us, gives us the opportunity to restrain global warming to 1.5 degrees Celsius and avoiding some of the worst tipping points. So we see that when we think about near-term carbon emissions, we're really focused on embodied carbon. When we think out into the hazy future, because buildings use energy a lot over time, it's operational emissions. The point of this talk is to talk about whole life emissions, how we think about embodied and operational emissions together. If we're just talking about embodied emissions that happen in the first year, so much can be done in terms of specifying better materials, using less materials, using biogenic materials that come from natural sources. But to pass it off to Larry, the most important thing you can do that avoids all those near-term emissions, so you don't have to be caught in these awkward choices between using a bad and a worse material, right, is to use what's already there and avoid building by adapting existing buildings. And I think I'll use that to tee up Larry for the care part of the presentation.
New building takes a lot of carbon to build. And over the next near term, the 20 years that we're really concerned about, it's about half the carbon. And so we've got to start building, well, either building low carbon buildings, which is hard to do, or just building fewer buildings, which is the one that I think we should be doing. So the other thing, that's just for new buildings. We have a lot of existing buildings, and operating existing buildings are still responsible for the majority of emissions. These are for cities around the world, and you can see that it ranges from 55% to 76% of our emissions in those are all from buildings. So it's a huge impact of just operating the buildings we already have. And the other thing to remember is that about 2/3 of the buildings that are with us today will still be here in 2050. So they're not going away. We've got to make them better. So this is really a pitch, not just for reusing a building instead of building a new one, but just for making our existing buildings perform better. This is a reminder from Architecture 2030 of where we need to be and how fast we need to get there. They think we need to be at 0 by 2040, but it's not just a straight line to 0. They think we need to be 50 to 65% by 2030, which is only less than 7 years away. So the steepness at the beginning of this graph helps us meet the target of 2040, which is what we hopefully will keep us under 1.5 degrees Celsius. The global community is talking about 2050. And if we did 2050, the steepness at the beginning would get even steeper. We've got about 340 million metric tons, I think, in that triangle. We've got to keep that the same no matter how we get there. 340 to 400 gigatons, not million, billion. Big numbers. All right. So this is another interesting thing, which is AIA did a survey last year and asked about the main reasons they got for remodeling buildings. And last year was the first year, maybe the second year, where billings for architects were greater for renovations than it was for new buildings. Mm-hmm. So that's interesting. It usually happens during a recession. It's continued after the recession. So we're doing a lot of renovations. But if you look at what we're doing, upgrading the shell, upgrading the systems, and energy performance are pretty far down this list. They're not the reasons we're doing it. And what we're saying is that they really have to be included in every project. We can't just adaptive reuse conversion, basic interior modernization without starting to address the operational emissions every time. Because there's an opportunity. You're working on the building anyway. So you've got to get in there and do some stuff. So greenest building is the one that's already built, but it's also, more importantly, the one that's been upgraded. So I'm going to talk about the CARE tool. In February 20 last year, Architecture 2030 launched this tool, a carbon estimating tool called the CARE tool. It's designed to do quick upfront carbon estimates comparing reuse project to a new replacement building. I've been working on this for about the last almost 4 years now with Aaron McDade of Architecture 2030 and Laurie Ferris, who's currently chair of AIA COAT and the Zero Net Carbon Collaborative and a lot of other things. And she's actually now working at Northeastern University at a research fellowship. So there's not a lot of us working on it, but we're trying. So it's an early phase decision-making tool. It evaluates total carbon emissions, compares the impact potential of existing building reuse to new construction. It does not do detailed energy modeling or whole building LCA. It does not allow users to override backend data, although you can override some of the default settings that are built into the tool about grid efficiency or your climate. If you have better climate data than what it defaults to, you can enter that. So you can make some changes to it. It's designed for stakeholders from across the building sector. And really, we're focusing more on planners, officials, campus planners than we are on architects and engineers. Since it's not really a design tool, it's really designed to help with early decisions about should we build a building or not? Should we reuse what we got or not? And there's lots of reasons to reuse a building or not, but we're trying to put carbon into that conversation. So if the owner or the client
Give you a kiss
or
right in your
everybody's
face.
interested
Yeah.
in saving carbon, that's the
Be
first thing they can
careful.
look at. Is
Yeah.
this going to save
Careful
carbon?
what-
Put a new building in, even if it's net zero or not. And it's really interesting what you get when you start feeding this into the CARE tool. So I'm going to do a case study of EcoBlock, which is a project our firm has been working on for more years than I like to count. Susie's the project principal on this. And it's a really interesting project and very different than the project you see from Jack, because it's a bunch of little single family wood frame buildings. It's a really different kind of building type than we usually use for carbon analysis, which is usually concrete and steel, big, massive buildings. So this is what EcoBlock is. It's a grant-funded study, creates advanced energy modeling. It's collaborative action, encouraging collaborative action to build community and improve community resilience at a block scale. And the reason it's at a block scale is if you can imagine doing the same amount of solar conversions on an individual scale, it's 180 individual projects or 9 block projects. So it's supposed to be easier. It hasn't always proved to be the case, actually. PG&E actually has some problems with doing things at a block scale, but it's happening. And it's actually going to have to happen at that kind of scale if we want to start. If we're going to meet Oakland's goal of being at net zero by 2035, I think, 2040, 40. Yeah, okay. Anyway, Susie should be giving this part of the presentation. All right. So block characteristics, there's 24 properties on the block. I think we're doing 18 of them or something like that, converting 18 of them. There's small projects, small buildings. They're pretty much all wood frame, 1 to 2 stories, built between the turn of the last century and the 1970s. There's 18 projects. So here we go. Energy efficiency. The project includes efficiency and electrification retrofits, shared rooftop PVs, shared battery and microgrid, if we can get the funding for that part of it, a shared EV charger for the block for a car, and a whole legal and financial structure of shared ownership, which is actually really key to making this work at a block scale. Here's the block. a very cool block. It's really, it really was a kind of a case study in how not only are we doing this great energy upgrade and this great climate project, but it really brought this block together. I mean, it was really this incredible, a few key people really wanted it to happen, and they brought all their neighbors on board almost. And it's just been this amazing sense of people at this scale and this kind of ownership and this kind of income level don't usually have access to impact anything about the climate. It's out of their control. And this is sort of saying, actually, if you do it together, you can make a huge impact. And I think that's pretty inspiring for the people that live there. It's been inspiring for all the people working on the project. So it's pretty cool. Upgrades, building envelope is pretty minimal. We live in California after all, it's a pretty mild climate. So they're doing attic and underfloor insulation, but they're not replacing windows. They're not doing wall insulation, which is too expensive. They're doing air sealing, which is critical. It's a thing that's pretty simple to do. And then a lot of mechanical and upgrade. Everything's going electric. So all the old appliances are being replaced with efficient electric appliances. They're doing a heat pump for hot water and heat pump for space heating. Putting in hoods, things to improve the indoor air quality as well, so ventilation. Outside, everyone gets a charger and a service upgrade if needed. And I think almost all of them need a service upgrade. Maybe not all of them, but a
Well,
lot.
they're actually
reconsidering that, and
Oh, good.
some of them are not requiring a service upgrade.
That's great. That's great.
Right, what is kind of a minimum service upgrade for a site? I have that stuff.
Well, you know, everyone tells you to go to a 200 amp service, but it doesn't, you can do it on a 125 amp service. Yeah, but you do have to sometimes do load shifting and things like that, but you can do it.
Yeah.
I just did it from my house and we went to 200 amps, but it's because we thought we were going to have an ADU in the backyard and that kicked us into the 200 amp. If we hadn't had that, we could have done it on the 125. So, and then rooftop solar, all the houses, well, you'll get to this in a minute, all the houses are different. So some houses have a lot of space for solar, some don't. So the idea is to put solar all over and kind of share it for the whole block, which PG&E also is having some issues with. crossing property lines of power and things like terrible things like that. This shows the difference in sort of the level of building, the performance of the different buildings. In a poor performing building, getting to the level we need is a 71% reduction in emissions by the time you get it to the level we want. But in a pretty good performing building, it's a 28% reduction. So every building is being brought to about the same level of performance. Some buildings need a lot of work. Some buildings don't need very much work. So it averages out over the whole block. So running this through the CARE tool, the first thing you do is what the screen looks like when you come up. There's these 4 tabs across the top of your screen. You input general information about the project's location. What that does is it sets the defaults. It sets your climate zone. It sets your grid, grid app, basic grid information about how efficient your grid is for the whole state. But you can go in, you can go in and change that. If you want to say, I think what we selected for here was on the grid stuff, we said, we selected it and we went to high renewables. By 2040, we're going to be at high renewables in California because that's their goal. You can leave it as it is, which is what it is now. You can say high renewables. You can say net zero grid by 2040, which most states probably won't meet, but California will get close. And then you put in the model time frame you want to look at. And because 2040 is kind of our cutoff line, we're saying 17 years from now. We want to know what the performance will be like in the next 17 years. Then you put in information about the existing buildings. And in this case, we just used a total square footage for all the buildings because they're all the same type of building, all wood frame. We picked the type of structure, wood frame hybrid, which is wood and steel or concrete, or a steel and concrete building. So you put in that information, which will generate some of the embodied information. You put in the use. There is no single family use in our calculator because it's based on the zero tool. So it's multifamily, which is about as close as we can get. And this will give you your basic operational emissions, just default operational emissions for this building type, existing building. That's about 2.7 kilograms per square foot per year for this building type. Then the next tab, oops, I'm trying to operate the tool instead of the, which I could do also. Then you look at the renovation options. So you set targets for operational, you estimate the % of structure and other parts of the building that need to be upgraded. So you put in the same information about, are you adding addition? What's the square footage that's changing? You put in a lot of information about your targets for building efficiency. In this case, we're saying about a 58% reduction in emissions was what this was modeled at. 100% renewables and all electric is what this building's going to be when we're done. All the buildings will be. And then you put in, there's these different tabs where you can look at the different types of building, different pieces of the building. So structure is the big one. In this case, we're not doing anything to the structure, so that stays 0. The envelope, we're doing nothing to the envelope. We're actually very minimal to the envelope. We're replacing some of the roofs, adding insulation at the roof level, which isn't counted with that. Interior reuse, we're leaving that alone. Mechanical's the big one. We're replacing all the mechanical systems, all the heat pumps, a lot of the wiring, some of the plumbing. So that goes up quite a bit. So this sets your embodied footprint for the remodel. And you get both operational and embodied footprint. And then the next tab is the new building, a replacement building. And you would, in this case, replace it with the same type of building, a wood frame building. You'd set this, we're going to set the same targets for this one. And the same, it'll be all net zero and all electric. And then you get the charts. And the existing do nothing, leaving it alone is about 800 and some tons of carbon over the next 17 years. The remodels I can't even read this, about less than, it's 130, I think. And the new building's about 360. So it's a huge, you can see the difference. And it's in the new building and the remodel, it's all embodied because they're net zero buildings. So there's no operational. So it's just a great example of sort of how this tool works, showing you the difference between operational and embodied and what you get from it. And you can see why, even if you're going for net zero, the difference between embodied emissions is really different between a remodel and a new building. So this was kind of a fun little project to do for a block. The renovation equals the number of emissions from the existing building, just leaving it alone after about 4 years. And the other one doesn't equal it until about 12 and a half years. And the reason that's low, that's actually pretty low. The reason it's low is because these are small, light wood frame buildings. The embodied carbon isn't that huge on wood frame construction. If these were concrete and steel buildings, the payback would be way down the line. So I think, these are just more of Aaron's little tabs that come up here. Pretty cool, huh? Okay. All right. Here we go. So these are some of the questions that you can answer by using the CARE tool. How much carbon can you avoid by building it compared to by remodeling compared to replacing it? What if you can only reduce its operational emissions by 50%, but you can replace it with a new net zero building? It's really interesting to put that in, because sometimes if you can go to net zero and you really can't make the building more efficient, sometimes the new building's a better choice. What are the impacts of geography, grid intensity, and condition of the existing building? It's really interesting to put the same building into California and put it in Tennessee or Wyoming and watch what happens to the grid. I mean, it's just the emissions are much higher because most of their electricity is coming from coal, so it's really high. So those are also really interesting. And then looking at bigger picture, can this contribute to carbon neutrality targets? And then if you're into historic buildings, using it to look at the greenhouse gas benefits along with historic tax credits, things like that. So there's a whole lot of things we're trying to do with it. One of the things that's interesting is that it's now set up to do it on a single building level. And the next phase of this project is to try and do a portfolio level. So you'd actually can look at a whole portfolio of buildings at once. A city planner could use it, a campus could use it. We've done one campus study, but we had to enter every building ourselves. And we're trying to come up with a way to do a portfolio. That's in the next round of funding for this. So that's it. I think I have to get out of this. Stop screen sharing. What do I do? Stop share.
Craig asks, do blurry faces contribute to climate impact reduction? Craig, the answer is yes.
What did you?
I don't know, just a silly question about blurry faces. Cool. I'm going to take it maybe from there, and I'm going to start as I do the tech stuff, asking the audience, people in this room or on Zoom, how often are you doing energy modeling on a project? Is this beyond, we'll say beyond Title 24, like a performance energy model? Is it all the time? Anybody all the time?
Some of the time?
The best of times? The worst of times? Anybody on Zoom want to contribute to how much they're doing energy modeling? I'm looking at the chat right now.
Chat too, and then I can.
Thanks. You look at the chat. What about, has anybody here, somebody says rarely clients are not requesting it. I do it anyway. Thank you, Craig. Anybody doing LCA or life cycle assessment on their projects, or has done a sort of embodied carbon analysis of any kind on a project they're working on? Starting a little bit.
Right.
A yes,
Good.
a yes. Okay, awesome. Doing it in anybody using Tally? That's a common one. Some people using Tally. Anybody using one-click? This is like the engineer's version. It's not very fun.
The finished version.
Yeah, exactly. Anybody using Epic or Care or Carbon Designer? Got one. Okay, cool. I mean, the nice things about tools like Epic and Care is they're nice kind of on-ramps into the wonderful world of whole life carbon. Even when you're getting energy model results, right? You're not getting carbon results. And I think there's always some work to be done about kind of crosswalking. Does that work? Oh, right away. I love it. Crosswalking energy to carbon, right? Not all energy use is the same. So you got to kind of understand how it works. There's all sorts of funky variations. We know in California that when you turn your lights on during the day, there's actually very little carbon on the grid a lot of the time because there's a lot of solar in California. When you turn your lights on at 6 p.m., okay, the grid is sometimes really struggling because everybody's getting home and turning the lights on, running their dishwasher, turning on the television, cooking on their electric stove. So there's all these funky variations time of day. So I'll just say that there's variation. There's a difference between carbon and energy. And tools like Epic and Care really help you, I think, make that translation. And I think both of our intentions did make it pretty accessible. One thing to talk about a little bit is when you use which tool, because this is like, there's a lot of tools out here. When do I use Tally? When do I use this or that? This is a figure that I'll walk through that was in a recent report from the USGBC and the Rocky Mountain Institute, their Driving Action on Embodied Carbon in Buildings report, that they think is that's being presented as some sort of a preview of what might end up in LEED v5. And the first question they ask is the building necessary? Are you considering reuse or retrofit? They say, what might you do then? If you're comparing retrofit to a new build, the first stop is care, right? In this sort of decision tree about what to do when, care is the first stop as you're considering this difference. Okay, are you comparing different new building options? For whatever reason, you weren't able to find a reuse strategy. And then it asks, are you looking for a rough idea or higher resolution of data? And I'm going to do this. They do it in a long thing. I'm doing it in 2 columns to make it work on the slide. Apologies for this. They say, okay, that gives you 2 kind of like a decision point here. Do you need early guidance to drive decision making? Or do you need detailed guidance? Because you actually already have the bill of materials for the project. Jump up to this side where it continues. If you're looking for early guidance, that sounds great. You have 2 choices. You can use Athena, the eco calculator, a simplified LCA, comes out of Canada, super cool assembly-based tool. You need to know a bit about the building to assign all the assemblies correctly. And it gives you all the different indicators, not just carbon. If you're just looking at carbon and looking at energy, this is where Epic, the tool that I work on, comes into the flow. And there's other things you can do, like Kaleidoscope is an excellent free resource from Payet, comparing different building systems. And then Carbon Designer 3D is an awesome tool built into the one-click ecosystem, pay to play, a little bit expensive, but a great tool. We use it sometimes on our projects as well. Or if you need really detailed guidance, you actually know a lot about the building. Maybe you're in DD, CD, you're in the procurement phase, you're doing an as-built. You can use EC3, which is an excellent procurement platform for choosing EPDs, environmental product declarations. That's just carbon and materials. Or if you're doing an LCA, you can use a tool like Tally, which a couple of people in this room have used, one-click LCA, or Athena again. So this kind of decision tree, again, lives within the USGBC and RMI report. I just want to use it because I think it's a great resource as everybody in this room and on Zoom and like literally across the world is trying to figure out which tool from the acronym soup to use at which phase. Okay, now my part of the show. I'm going to talk about Epic, which is our early design tool we've been working on for a couple of years. But really, I think another thing I really want to call out here is that, yeah. Oh man, sorry everyone.
Too many steps here.
Yeah, gosh, sorry y'all. Okay, how about now? Oh, I see it. Wonderful. Happy to share slides at the end of the presentation too, if it's of interest. But then early phase carbon assessment is really just one stop along the way. The goal is to have this in whatever way we can integrate in our design process. So as we're making decisions on a project, we're getting some feedback, about the carbon emissions on it. Epic is one tool to do that, but it takes a village, across a project and across the landscape of software solutions. So I'll talk a little bit about Epic and give a demo. I think that's the easiest way to do it sometimes is to do it live. Epic, like Care, is a whole life carbon tool, embodied carbon, operational carbon, and landscape strategies as well, hardscape, and as of recently, actually refrigerants, all this stuff that moves through the pipes. There's a lot of different strategies you can use or investigate with Epic. The question is always, well, what's the best thing, the one thing I can do on my project to reduce its carbon emissions? And the correct answer is it depends. Epic is a tool for investigating what it depends on and making your own kind of strategies and determinations. For a long time, these decisions were made by a few firms, by the experts at that firm who've been doing this for 10 years and could stick their finger in the air and sort of figure out which way the wind was blowing. The idea of tools like Epic and Care is that this actually needs to be in the hands of every designer on every project. And actually a lot of those experts, right? Maybe do a lot of projects in California. Like Larry was saying, if you do that same project in South Dakota, you're going to see a totally different set of patterns where the materials come from, the local concrete that's available, the grid you're attached to. So that if we're making decisions based on our local context, actually, we need a little more data before we do projects other places. Tools like this that contain that data help designers make those decisions. This is kind of a dorky slide, but are people generally familiar with the stages of a life cycle assessment for a building? I can use this slide to walk through it. There's the where the materials come from phase, the production of those materials. They come out of the earth, they're transported to some sort of factory, they're manufactured. From there, there's the construction process from the factory to the job site, assembled on the job site. And that process from the raw material extraction to its installation, that's the A phase of buildings. The B phase is all the things we do day to day, like living in buildings, the use phase of buildings, maintenance, repair, mowing the lawn, vacuuming the carpet, replacing the drywall, repainting, doing the facade upgrade, year 20, using the energy every day. And then the C phase lives in the distant future. And this is the end of life of the building when it eventually gets demolished, disassembled, sent to landfill, recycled, whatever else will come to it, incinerated. And then the D phase is this special phase that we use to talk about things that are related to the building, but not in it, and typically benefits. So for instance, if we are generating solar energy on site, that's great. We're not, producing any carbon emissions without electricity. If we're going to make a claim that we're actually displacing carbon emissions that would otherwise happen on the electrical grid, that's a D phase thing. We're making a claim about we're doing something on the building, it's important. Something else is happening in some, other part of the world. That lives in the special category where we talk about it, but we have to sort of put it in air quotes because it's not a direct, we're not actually not avoiding carbon. We're incurring something happening elsewhere. Or when we talk about timber, you say timber stores carbon and it's, that's true and important. And actually the sequestration of carbon in timber happens in the forest. It doesn't happen in the building. So that sort of sequestration of carbon is also a D phase thing, something we count, something we care about, but we sort of have to put it in brackets off to the side. And these are the sort of components of a life cycle assessment that the goal is to mention or to measure through this process, all these different impacts and benefits. So typically when you say if you're doing an LCA on a project for lead points, you are looking at the core and shell of the building only. For a long time, it seemed like embodied carbon snuck up on people. People were really worried about energy use, had it kind of figured out, and they're like, oh my gosh, all these materials go into buildings, and we had never really considered this before. If you're just looking at core and shell, you're really in for a treat because a lot of other stuff goes into a building as well. And we're really trying to, in Epic, expand the scope of the analysis so that we're not blindsided again in 5 years. Okay, we sort of figured out concrete and steel well enough. Well, then the things we have to worry about are the MEP systems, the solar panels, and other clean energy stuff that has emissions associated with it. Hardscape, everything beyond the building. Interior fit outs is a really big contributor, especially in retrofits and all these other kind of contributors to emissions from a building. So the goal of Epic is to sort of put everything on the table and let project teams figure out where the biggest impact is to be had. This is the kind of anatomy of the model, and it's a simplification in a sense, but it's all true. What Epic does is you define in the tool a basic building, a sort of shoebox building. And then from that building, you define the model does a set of material takeoffs, a set of assembly takeoffs. So it says there's this much concrete in the structure. It says there's this many square feet of envelope. And it says the building uses this many kBTU of energy per year. against each of these takeoffs that happens against the building, we assign a set of GWP factors. GWP is global warming potential. So the carbon emissions associated with the concrete, with the envelope, with the energy use. And then that gets all rolled up into the results of the model. So it's this pretty simple process: define a building shape, figure out what's in it, add some carbon data to what's in it. And then what you get to do as a user of the tool is play with all those little toggles, change the shape of the building, change what the materials are going into it, change the amounts of different assemblies, right? And change especially the carbon intensities of those materials. That's sort of the purpose of the tool. And then in the tool, you'll see there's pretty good documentation, we hope. It's been developed mostly through feedback from people using it to make sure that all the data behind the tool, its assumptions and its methodology are transparently communicated so that it's helpful to project teams in setting goals on projects. So a case study, and I think an important one related to the tool, is EHDD right now is starting construction on the AIA headquarters in Washington, DC. This project started back in 2020, and Epic was a big part of actually us winning that project. Like Larry mentioned, the AIA in the brief they set out for the project said, hey, we really need to reuse this really important, architecturally important building. You know, the problem is it's all concrete and we really need to get near to net zero energy, but actually there's a limit to the efficiency measures we can sort of like, you know, make good on in this building that we kind of need to preserve for a lot of other reasons. EHDD's response to this, using a sort of early version of Epic, was to say, that's all well and good. We're going to take efficiency as far as we can in the building. Like using less energy is important for many reasons, but really what we care about is carbon and climate. And it's actually not just carbon emitted in the operation of the building related to the energy. It's also the embodied carbon of the building. In fact, what we're going to do, now I put this in, we can come back to that, is we put forward on day 0 during the interview phase of the project, we used Epic to sort of show basically this strategy, where if this is emissions from new construction, here's the year 1 emissions, there's all these little replacements over time. Here's the accruing emissions, right, from energy use. If you retrofit the building, your emissions in year 1 go down to very little. And there's still some emissions over time, obviously. We haven't done any energy retrofit so far, right? This is just preserving the building. We're going to increase energy efficiency and electrify the building. That helps us force that curve down in the way we saw earlier. For any energy left in the building, we're going to make sure we're procuring 100% clean power through an agreement with the local utility. That gets us to approximately 0 carbon energy. We can, you know, there's a little bit of probably emissions left over because of these variations in the grid. And there's still all the embodied carbon left over. This gets to the earlier points about like, actually building has environmental impacts, and it has environmental impacts we can't ignore. But what are we going to do about this remaining embodied carbon? So beyond reducing it to an absolute minimum through retrofit strategies, through a ton of reuse strategies of almost everything we could in the building, and a low carbon specification of things like concrete, we proposed to the AIA that we would enter into agreement with a local set of Habitat for Humanity projects where we would fund dedicated community renewables on those Habitat for Humanity projects. And the carbon savings, like they get the, you know, they get the free energy from the solar panel, and the carbon that's avoided becomes the sort of offset, for lack of a better word, that the AI is investing in to connect the decarbonization, the full decarbonization of the headquarters to the AIA's goals for sort of social equity, right? Like trying to combine decarbonization and social equity, often viewed apart. Our argument here during the proposal was that these things were equal. The problem that EHDD ran into is that for this to work, right, we're committing to a certain size of solar array that we're saying the AIA is going to buy on these, you know, on these affordable housing developments. And that means that there's a financial kind of, there's a price tag we put on this, right? So this actually makes it really important that at the very beginning of the project, we're pretty confident about what this number is, the carbon we're saying that's going to go into the building, because it's not just a number we're throwing in the air. We're saying that like, here's an offset strategy that is like, has, I think, a lot of importance for the AIA, and we're going to meet it by hitting this target, right? So we committed to that in the interview phase of the project using Epic. And this is the slide from the interview that laid out some of these strategies. Here's the energy efficiency strategy you saw. Here's clean electrification with the procurement of renewables. And here's the local carbon offset project. This was like, obviously winning a project has lots of components, but I think the ability to make this proposal at the beginning of the project and commit to these numbers, which were fairly aggressive, before we've like probably even walked the project more than once, right? Was I think compelling.
With that,
To the client.
we have to say how much that was going to cost for the project. Was that part of what you had to say at that proposal?
It was all I think there's another wrinkle here actually, where the first thing proposed was that we really wanted to do a set of boiler replacements on schools in the area, because it's another thing is like you replace these old boilers. That didn't work out because once you replace the boiler, you touch a lot of other systems.
Right.
So what it cost to do this project probably changed as the strategy changed.
Sure.
So
Sure.
I'm kind of omitting some of that because we had to change approaches because of the complications of doing boiler replacements, but that was the idea at the time when we started. So we set this carbon budget in the interview phase, right? Like at the very beginning of the project. And then like this year in March, we got to 100% CD. I put a little bar in here to say that there's still a little bit of uncertainty. The building's not built yet. The concrete's not all poured, right? Like we don't know if this is actually going. The process isn't over until it's over. But 100% CD, we were at this line, which was to say like we were within 5% of the goal we set at the beginning. And this wasn't because Epic is a perfect tool for understanding everything that goes in the building. No, like all these early design tools, it's a goal setting tool. And this, I think, shows the importance of just setting a goal early is what allows you to meet that goal at the end of design, right? If you don't set the goal and you're just sort of stumbling along through a project, you'll get somewhere. But if you set a goal, and with this process of doing LCA in every design phase, this is what kept the project aligned with our carbon goals, right, through time. The path is, as much as like diagrams might show, goes A to B to C to D. It was a pretty twisting path. Design is a complicated process, but Epic allowed us early on to set the goals that allowed us to meet them at the end of the project. So I think there's a little bit of time left over. I'm going to do, if there's just a demo of the tool to kind of walk through it and to talk through some of what it does. Maybe I'll zoom in a lot more of the screen. Is that kind of legible to people? A little bit-ish? So the idea in Epic is that you can, first, you have to agree to this disclaimer. It says EHDD cannot predict the future.
Oh, come on.
I know. No, people like anecdotes about that. We use these projections put together by the National Renewable Energy Lab of what the electrical grid is going to do between now and 2050. Right. These changed drastically between 2021 and 2022. Does anybody know why? The IRA. Not because the IRA itself decarbonized the electrical grid, but because in the way we expect the electrical grid to evolve in the future, the change in solar incentives, minor as they may feel sometimes within the IRA, totally changed our projections of the way the grid will decarbonize, because it changes some of the basic fundamental math, like the economic math behind the grid. In California, we were totally wrong for a year because the Diablo Canyon power plant, right, everybody thought it was going to go offline. And then the governor said, we're going to keep it online for the next 10 years. Right. Okay, like we don't know these things are going to happen in the future. Epic is a forward-looking model. The future is uncertain, right? This is the disclaimer. But the idea is that once you accept that fact, you can get some idea of the carbon emissions over time pretty quickly. So let's just call this the AIA East Bay office. And it's a project we're going to complete in 2025. I'll use my home zip code because I bet it's the same one as here. We'll say the default structural system. We're not going to try very hard. It's just going to be reinforced concrete. It's going to be an office with 4 floors, maybe 3 floors like this building, and the floor plate's approximately 10,000 square feet, making stuff up. So the idea is like, these are the numbers you have, in the little brief you get from a client, maybe just in an email, and you can start to put together strategies about ways to reduce emissions. There's a lot of stuff buried in here in this base case tab. If you look here, override default assumptions, that you can really go to town on to tune different parts of the model. I'll ignore that for now, but probably if you're ever using this on a project and putting some like a financial agreement, we'll say behind it, you should look at those and make sure they track with what you're doing. We do a lot of site landscaping stuff. I'll gloss over that too. So this is the approximate breakdown in California of this sort of default baseline building of operational embodied carbon. Let's go to somewhere else in the United States. Does anybody else know any other zip codes off the top of their head?
745. My mother, she lives in Oklahoma. 74505.
74505. All right. Doesn't exist.
Sorry.
Anybody got another one? 01451. All right, awesome. Whoa, the Massachusetts grid isn't going to be as clean as California's, right? Over time. What's another one? I know a New York one off the top of my head. 11238. Okay, somewhere in between California and Massachusetts is New York City. Did you figure out Oklahoma?
I got it.
Yeah.
74501.
All
Oh,
right, Massachusetts-ish. But we'll see other funky patterns here, right? Because you might be in Massachusetts and the grid looks really dirty, but then you put a solar array on a building in Massachusetts, which we can look at here. You put 10,000 square feet of solar, it's going to do a lot less than the same 10,000 square feet of solar in Oklahoma.
Put
We
in,
can-
put in 82001. That's Cheyenne, Wyoming. I'm curious if Wyoming.
Did I get that right?
Yeah, he would. Yeah.
Okay, but I want to go back. Can you say the Oklahoman one more time?
74501.
74501. Okay, I'm going to try to remember that. That puts us here, and I'm just going to preview some of the, then basically you set the base case, then you do a bunch of stuff to the building to see what it does to reduce emissions. One of the cool things we worked pretty hard to do is have a little solar calculator that talks to some NREL tools down here under operational carbon. Let's say we put in this 10,000 square feet of solar. So I'm just entering 10,000 square feet of solar in this building in Wyoming. It does not very much, but let's say it's going to take up 22%, or let's just look at the reduction. What's this reduction in the final year? 140 tons of CO2, actually not shabby. If we go to the base case and change this to, what was the Massachusetts? 01451. 01451. That'll recalculate to there. We go back to the reduced emissions. And we see that the same amount of solar only reduced 40 tons of CO2, right? We're doing a ground up school right now in Utah. If I'm going to make the set of assumptions I would make in California for the way we balance our energy strategy for a building in Utah, and I'm just making it up, right? As we're going after a project, I'm probably going to be wrong. Understanding these trade-offs between the electrical grid, this, that, and the other, it is helpful, we'll say, to have data, data-driven tools like this.
Is the grid just as it is right now, or is this projecting over the next 30 years?
This is projecting, yeah, with the data from NREL.
Mhm.
So on top of this, like we put a little bit of solar on it, we see that this solar produces 16% of the energy from the building. Well, let's set an EUI target in this building of 45. We see the emissions reduction from that. We can save this scenario. This is going to be solar and energy efficiency. We'll just abbreviate as EE. And then what we can do in Epic is we can make another scenario, and we'll say it's a copy of the current scenario. Makes a little copy. And now let's do, let's say the AIA East Bay headquarters, which I think is in Massachusetts now, is
So there's an East Bay.
exactly, yeah, just a different bay, right? If we do a wood frame building, Larry mentioned that a wood frame building is actually super low embodied carbon. People like mass timber. We do some mass timber work, very nice. Mass timber, the word mass means there's a lot of it. The nice thing about light wood frame is that it's light, right?
Yeah.
So we'll say, like, instead of being a reinforced concrete 3-story building, what if we have this as a light wood frame building? We see a reduction in embodied carbon in year 1. And what if, there's always some concrete and steel in all these buildings? We're going to make sure that everything we procure is super low carbon, the lowest carbon stuff we can find in the local area. Right? You can just sort of set these settings. And you probably have the question of like, what does it mean that it's low carbon 20th percentile? Any of these question marks in the tool bring you to the documentation, which once it loads, gives you these data readouts, which says, oops, these are the things you're committing to by making this choice. And then you can take this forward to your other procurement tools. You're looking at environmental product data, right? And this becomes your way of setting those goals. So,
And are those typical goals for the whole country, or are they tied to the state you entered?
so for any sort of wood products and steel, it's national,
Right.
Because the supply chains are national.
Right.
Concrete is hyper regional.
Right, okay, good.
And we use data from EC3 to do the concrete carbon emissions. So the unfortunate thing about that we're working on a little bit behind the scenes is because we can't just publish one number for concrete. This is a very useful number for a project team to have, but it's going to vary. So we're going to find a way to get that into the tool at some point soon. Once you've made a couple scenarios, you can do cool stuff like compare them. So these are the figures that we'll often use in our presentations. Here's our base case, business as usual. Here's the solar and electrification strategy. You see this increase in embodied emissions from this to this. What is this from? Solar panels, right? We still see a reduction in embodied carbon or in overall carbon by the final year. But obviously there's trade-offs when you install solar on a building. We have a wood frame building, we get lower emissions. I'm not super satisfied yet. So let's try to put together a scenario where we can really push it all the way. So I'm going to start actually, I'm going to select this wood frame scenario that we made, make a new scenario that's a copy of that scenario. And with it, we're going to procure really responsibly sourced timber so we can claim the climate benefits. So we know where it comes from, a transparent and traceable timber supply chain. And it's going to be FSC certified, we'll say. That's enough to be able to claim these sequestration benefits, the carbon stored in timber. We've made some vouch for the forestry practices that we're procuring from. The envelope, we're going to have a really low carbon envelope. And it's going to be refurbished not every 30 years, but every 50 years. So long-lived, low carbon material. Does it exist? We hope so. Interiors, a big contributor. You know, you see, actually, this is a classic point. Once we've done a great job reducing carbon from structure and envelope, these are the things that people usually care about, right? And this is sometimes where some people stop. But if you go to these other charts, here's the embodied carbon budget. Envelope and structure, we've done a great job. What's left over? MEP systems and interiors, like much larger proportions of overall emissions. This stuff adds up to a lot.
Because the interiors get replaced 4 or 5 times in that time period, and the
Exactly.
structure and envelope stay the same.
Mhm.
So you're
Yeah.
it's small, but it keeps getting redone.
So we're going to have really low carbon interiors. That helped a lot. And MEP, there's not clear pathways right now to low carbon MEP systems. I wish I could tell you otherwise, but we're at least going to make sure we replace them every 30 years and not every 15. So this starts to get you at some of these trade-offs, you know, around embodied carbon in buildings. And if we say like, okay, still not very satisfied, we really want to go farther, we're going to set an EUI target much lower. Like, let's see if we can get to 20 on this building.
And does that include the on-site solar energy production?
This is absolute energy used by the building.
Okay.
So before the solar comes off of it. And then let's say, I want to calculate solar differently. I actually don't like this square feet. I want to know by percent of load, what does it mean to generate 150% of the load I have in this building with solar? What is that going to take? It'll do some math and it says it's going to take me about 16,000 square feet. It'll be about that big of an array. And you start to see we're trying to pull that net emissions line down through all these strategies. So
What does the green represent?
yeah, the green is stored and avoided. This is the module D stuff. So the two things showing up here are the carbon sequestered in the timber structure and all of the additional energy I'm producing from the PV because I set it to 150 instead of just 100.
And then, I'm assuming from the way the chart reads that there's no end of life, like when you have to give back a sequestration.
Yeah, that's correct. So we cut this at 30 years. to sort of prioritize short-term decision-making like care. There's a little bit of funky math around sequestration that we do here, which says that if you're counting sequestration in year 1, you also need to count end-of-life emissions for timber only. So you sort of have to reach into the future, pull those emissions back to year 1 to do that accounting. That's baked in here because that's what makes it like reasonable, you know? But you're right to say that this isn't 60 years like most LCA timeframes are. So then like these might be the, you know, the scenarios we'd present to a client on a project, right? Here's 4 paths to reducing carbon emissions from this building. Or 3 paths rather. You know, the easy one, the ambitious one, and the aggressive one. And then this becomes the way we structure early conversations with clients. Might add a little more resolution to the model to figure out some of the corner cases. You know, there's always, every building is particular. And then we try to move this forward with the targets we set here into the next phases of a project as we move into something like Tally, or eventually move into something like EC3 to do procurement. And it's, I think maybe, I don't know if either of us actually mentioned this, but both of these tools, Epic and Care, are free. And a lot of people are using them. So this isn't a sales pitch. Go out and use the tools to design low carbon buildings. This is my only ask.
Yeah, there are 4 tabs on care. If you kind of know the basics about your building and some ideas about what you want to do with it, it takes about 15 minutes to fill it out. It really doesn't take very long at all. And then you can go back once. We don't have as many great save options as Jack does yet. We're working on that. But then you can go back and start. You can save an option as a PDF, which this whole report prints out in 4 pages of the building.
Pass it around.
Yeah. So this is the eco block. See if I've got the whole thing in here. No, maybe that's it.
You just got the good stuff.
Yeah. Yeah. Doesn't have a chart on it. I was looking for the chart. Anyway, that's okay. This is how it prints out, and it shows all the data that was entered into that project. But so they are really easy to use, and if we can get this care thing, I really like what Epic does of being able to do 4 scenarios really quickly. Because I think that's still missing. But the main point we're making is not how to make a building better. We're making the point about, does it make sense compared to a new building? So we're not looking at optimizing the new building yet or optimizing the remodel. Eventually, the care tool will probably have options where you can, the remodel itself will have low carbon options for the remodels. Like right now, we just have low carbon concrete, we have FSC wood, we don't have low carbon insulation. We don't have a bunch of things in the tool yet that will make it. Because you could, I mean, the thing that's great about carbon sequestering materials is that for a renovation, if you're mostly working interior, that's the perfect place to use bio-based materials because they don't perform that well in the rain. If they're inside, if it's a bio-based wood product, keeping it inside the building is great. So it's a great way to use low carbon sequestering materials on a renovation.
Question, did you say you were using this approach on the community involvement?
We ran that project through our care tool to see how it did. And there's a lot of more detailed analysis because this is done with what's the group at Berkeley that we're working with, the Center for Energy Efficiency. Who's Teresa?
Amy Dryden.
Amy Dryden, and then all the analysis that Berkeley's done too on just the performance and stuff of the building.
The
CIE Center, yeah.
So I have a question, Jack. Now's the appropriate time. So we have a lot of clients who are nonprofit organizations,
Yeah.
mission driven, not a ton of money. And how do you, how does cost per square foot, how do you answer that question? How do you compare this to how much more or less it would cost you to go with the, the most aggressive carbon, carbon-free approach versus,
Totally.
Business as usual?
I think there's like one thing that I'm always wanting to harp on, an example from one of our projects maybe, is we do a lot of university work. We did a project recently for CSU's Stanislaus State, the Child Development Center. Little campus, Central Valley, great client, not a gigantic budget. The thing we did that reduced embodied carbon on that project wasn't some fancy new concrete mix, some super expensive material. we took the steel trusses spec'd by the engineer and we replaced them with gang nail wooden trusses that every home builder uses, right, across California.
Killing me.
And it's like, this is, I mean, it's like, there's a lot of ways that like people are making upsells, people are asking for the green premium. There's like, you know, there's a lot of really simple things you can do. Interiors, like we do a lot of interiors work. One thing we try to do that's really difficult to do, mostly because of the way procurement works, but might be actually easier with smaller clients, and we're able to do with the AIA, is reuse, right? You can fight all day to find a chair that has 20% lower emissions than another chair. But if you can get 1 out of every 5 chairs reused from somewhere else, you reduced embodied carbon from, you know, your seating by 20%. Really, like at a, you know, and you're not paying an upcharge for it. In fact, you're paying much less. Finishes.
2 out of 5.
Look at that. Yeah, 40%. You've hit your 2030 goal. You can go have a glass of wine. You're done for the day. Do you have like thoughts on the cost?
I mean, it's sort of the way we've done our whole practice all along, which is just to keep it really simple and build wood buildings. I mean, that's, we're even shied away from mass timber because it feels like most of the large scale buildings don't need mass timber. You can do it in light frame construction. It uses a lot less wood. You know, so some people were saying mass timber is great because the more timber you use, the more carbon you're sequestering, which it's not really the way I look at it. It's kind of sequestered, like Jack said, in the forest, not in your building. So using less wood is still a good thing to do. And the other thing I think that we don't have good data yet on MEP systems, on the embodied carbon content of MEP. It's still pretty nascent figuring that out. But the studies they've done have mostly been for commercial buildings. So we're going to try and, we think that using small scale residential sized PV systems, even for larger buildings, that's what we did in Portola Valley. Those were all residential scale, really high performance heat pumps. And it worked way better than these big, huge heat pumps used in commercial buildings. You use 2 or 3 of them instead, and you get a much higher efficiency. So I think that you get higher efficiency and you can get lower embodied carbon by just keeping things kind of small, or maybe even like sand and water heaters. Now you can just stack 2 or 3 of them up together and do it that way. So I think there's ways to do this where I guess the bottom line is simple and small. Even if you have to build a big building, break it into simple and small pieces.
So one follow-up question, and then I'll stop. How do you get your clients to care? I mean, all puns intended. But you know, how do you? We find it difficult sometimes to even we want to match their mission with environmental goals, and it's like I'm just trying to run a daycare.
Exactly.
It's like,
Yeah.
so great, but how much is it going to cost? And that's not my issue.
Yeah.
So I'm just curious to hear what that pitch.
So strategies from the field include, sometimes we actually just first try to get really, really good alignment across the whole consultant team. If we can get every consultant on board, then we have a nice united front, and you know, we can avoid situations where the architect says all electric's really important and the MEP person says something different. Right? Exactly. Like, so that internal, super important, right?
United front. That's good.
There's like also a lot of ways that obviously you can't do everything. And I think one use of tools like this is to understand what's big and what's small. Like sometimes on projects, we're fighting tooth and nail over a concrete spec. We zoom out, the concrete spec is this big, you know? Interiors is this big piece of the pie. MEP, okay, can we actually increase the insulation a little bit to knock down the size of an MEP system? This is like, you know, this is the hot stuff, right? Like, how do we make sure that just through efficient building design, we can actually just remove a bunch of stuff from it? So always looking for stuff like that, you know?
Thank you.
So I want to make sure that the people on Zoom.
Yeah.
So Jack, you have access to the questions in the chat. Do you mind being MC a little bit on?
I'll look at it too. Totally. I'm going to go up to the, maybe this is a good question for you, Larry. What is the incentive for a building owner to make a building more efficient? I haven't run into a building owner yet. I'll add to Lisa's question. Sorry for the amendment. That will do this out of the goodness of their heart.
Oh, golly. I mean, obviously, if the building owner is paying for energy, one of the arguments is cost, but sometimes they pass it on to the tenants and they're not even paying for it. I don't really know, and we haven't found good answers for this, really. It's just you do appeal to, you try to find out in their mission sometimes what's important to them. We had a project where they were committed to green, but they were really committed to saving trees. It was a rural area and they really liked trees. And so we sort of focused on that. And that was sort of our in to sort of saying, we're going to reuse wood, we're going to use FSC wood. And the reason we're doing it is because it's saving forests and it's preserving forests. So you look for ways that align with what the clients said they want. Sometimes the client, like Susie said, just cares about running a daycare center. But even then, you can sometimes enter into it through health or something, occupant health or something like that. Fewer emissions, going all electric reduces indoor air quality, improves indoor air quality. So you look for the ways that do align with what they're trying to do, and then you go in from there.
Absolutely.
So, yeah.
There's one thing I think to speak to a little bit here. Sorry, scanning the questions about the mention of the CalGreen mid-cycle update. Maybe worth mentioning that this is, you've gotten the carrot presentation. This is the stick. In the CalGreen 2024 mid-cycle update, some embodied carbon reporting is mandatory for all buildings above 100,000 square feet or schools above 50. There's 3 pathways that I'll speak to briefly, but there's more information on the internet. And happy to follow up over email with more resources. One is a reuse pathway. If you can reuse a certain percentage of a building, check that box on your CalGreen checklist. Another is targeting the highest emitting materials, glass, concrete, steel, et cetera, et cetera. They have thresholds listed. You prove that you're below the thresholds for those materials. Check, check, check. Then you can pass, right? Then you're to code in California. This is a code requirement. And the third pathway is the holistic one, which is understanding, we're going to do the life cycle assessment and make a whole building reduction of a threshold that I want to say is 10%. And then there's a separate piece of legislation that was passed last year that the California Air Resource Board is holding and is going to move into requirements around 2027 that will ask for a higher percent reduction that might ratchet up over time. So not only this stuff being done out of the goodness of people's hearts, a lot of it is being legislated, right? And those legislations will become constraints on architectural practice. For the better of the climate, some designers might be frustrated, but I think there's also, like we mentioned, a lot of design opportunities.
I've seen some of the frustration already in emails about how am I going to find a consultant to do this? And so far, we were in conversation during that cold cycle with whether they would allow things like CARE and EPIC to be used to do those. And so far, no, but I'm hoping that that's the way in, is to have it really simple. If you have to have a consultant that does a full tally analysis of everything, either you can't afford it, you don't have the time or whatever, but if it can be something that any building designer can fill out in 15 minutes, that would be great. So that would be another push to get the code to accept CARE and EPIC or some tools like that that are really early step, early phase.
I'm scrolling through questions, but are there more questions from the audience or anybody else watching the chat? I'm afraid. Yeah, please.
Now, is that being sponsored by PPP?
No,
So
California Energy Commission.
it's a grant, it's a UC Berkeley grant, application that they won. There were 4 organizations that, and they're moving forward with it. So this one is all grant funding, everything about it.
Okay, so then the homeowners get the shared PVs, they don't have to pay for it.
No, correct, and it's a very unusual model that will not be repeated. So part of the challenge is coming up with other models, financial models.
And hopefully we'll learn enough about how it works to be able to put together a model that doesn't rely on grant funding to pencil out.
Yeah, because I mean, it seems to me that, I mean, a lot of what we just say, single-family residential, I mean, because most of these carbon emission standards don't even really apply to the project that we're going to do, mainly restoration, rehabilitation.
Right. Yeah.
Right, but I mean, if you're talking to a homeowner and they want a solar system, it's like $20,000-$30,000.
Yeah.
In their 60s, and they're going, oh, then we're just thinking 80 for itself. There's no incentive for it.
Yeah.
What is the PG&E situation right now? You mentioned that
Oh.
PG&E was having.
Oh, it's what they call it tariffs, the fee system, and the situation is, you know, put this really done simply and probably slightly incorrect, but here goes. The minute you throw an extension cord over your property line to share your power with a neighbor, that power belongs to PG&E. Because you are not allowed, you are now.
You're not a power
energy-
company, right.
You're an energy source, you're a provider, and the original agreement was PG&E owns the power and goes so that's the issue. To come up with a shared model for the solar system, no two roofs are created equal, some are better than others for orientation and solar panels. That was the idea. We're just going to put the panels on the roofs that are
Optimal.
but you can't do that with the current solar system. To have each of the metering is still individual, and to get everybody on the solar metering program, every structure, so some only have 2 panels just to get them into that tariff. So there's things like that. It's not set up. PG&E is currently not set up for existing shared use. The law kind of organized a retrofit, a homeowners association, so that they could collectively own these shared assets. And it's a HOA agreement. So we retrofit the neighborhood with HOA. There was a legal advisor, an attorney who helped draw that up. But there's still neither the city nor PG&E it's an experiment, right? We're learning as we go.
Learning what the roadblocks are. It's a mandate that it's not really funded yet, or even, you know.
We packaged up all our permits and said, here they are, you know, all 1428, all together. And then what are we supposed to do with this? We do these by the grass, you know, so there's some learning.
I'm sensing a future program. This project.
There is. You can do, there's 100,000 of those homes, existing homes that have gas in them in the city of Oakland, that are supposed to be net zero carbon emissions by 2040. If you don't, you can't do that. So something's.
Did you have a question? I saw your hand.
Eco Block is good. I'm thinking about Eco Block in downtown San Francisco in the financial district. It's about 3 million square feet on a block. And I'm curious, we're all talking about what we're going to do with that square footage, right? And it's a 2-part question. Which is the best tool if you're thinking of converting that to housing and you want to run a comparison, demonstrate that. New construction versus use. But 2, I'm super interested in the issue of the incentives, how to start out monetize some stuff. But is there any talking about that with these commercial businesses? It is so expensive.
Yeah.
There's such different animals. And even if the valuation drops, which it will, I just think that's simple.
Is it more expensive than building a new building? You think?
I think, yeah, in a lot of cases, and there are lots of components. Sometimes it's just scale. Some of these builders just don't even build houses at that scale. So what are they going to do in stages? Because they don't market, 1,000 units in market 100 units.
Right.
There's just lots of components. And I work in the multi-family. So it's a tough one.
It is.
It's a really tough one. And then, of course, I'm reading Ministry of the Future.
Oh, yeah, yours is very good.
So, I leave it. Anyway.
Maybe to make one comment about the retrofit thing. I mean, the clear tool, I think, for this is CARE's definitely the place to start. There's been examples in New York City of people doing pretty complicated commercial to residential retrofits. There's one where they literally cut out big sections of the floor plate to make atriums. These were just developer spec projects, There was ways of making it pencil. The exact conditions or like the shape of that pro forma is unknown to me, but there's clever people out there trying to figure it out. And I have a feeling that the carbon piece of that will be a piece, but it'll be like you're saying, just because it could be so much cheaper if you're a clever developer with the right team to do it. You know?
To have a tax credit.
Yeah, for sure.
It surprises me that it's more even, I mean, because building one of those buildings from scratch is not a cheap proposition, those big, huge buildings. And converting them still is more expensive sometimes. And I believe you, you do stuff and I don't, but
Correct,
Yeah.
I mean, what about the carbon budget? Which is more expensive carbon wise? Building a new,
oh, well, the size they're building, it's gotta be steel and concrete, so it's gotta be higher carbon to
Yeah,
build a
that's
new
why I
building.
tried to put a value on the carbon you say.
Yeah,
real value,
yeah,
tax credit as a way of, because you're gonna say. carbon.
Incentivize.
yeah.
Why
I
are
mean,
we?
it's gonna depend on the building, but some of them absolutely it will be more expensive than building. Gotcha. I mean, I'm not cutting a hole in the building. Well, just think about that structure, you know, what's really involved in that. I mean, it's like, well,
And then the change of use, you go from a B to an R, and that's a different code altogether. I mean, then there's a lot of carbon and upgrading life safety
Yeah.
to meet current code.
Absolutely, yeah.
How do you come to terms about, production, day-to-day production of energy, use of energy? When our energy comes from coal-fired, gas-fired, hydroelectric, nuclear, natural gas, all very disruptive to the environment. How do you approach that? How do you address that issue?
What's the alternative?
You don't use energy.
Well, that's great. If you can design passive buildings that don't use any systems at all,
Right,
that's the best solution. Just like reusing a building is the best solution. That's the baseline.
right.
But
Should we only be practicing that? Shouldn't that be our goal as architects?
yeah,
Passive first.
yeah, for sure. But I then the question is, you have a lot of existing buildings, like we have billions and billions of square meters of existing buildings worldwide, and probably making them all net zero and passive standards is going to be impossible. Do you tear them all down and build passive houses or passive buildings? I don't know if that's a better solution, because we're talking about total carbon. So you're talking about the energy, which is huge.
Yeah.
The embodied energy is huge also.
Yes.
So our point is, we can't really afford to leave them as they are. We can't really afford to replace them from a carbon standpoint. So we just have to figure out how to make them better, and to make them not just better. The energy efficiency standards in this country, typically when they do energy efficiency incentive programs, it's 20% improvement. Europe's doing 50 to 90% improvement on their buildings. That's
So should we be,
what we should be doing.
leaders in
Yeah,
promoting a much higher standard?
much higher standard. That's right.
Yeah.
And it comes insulation and glazing, or reducing glazing, and some of these big glass and steel buildings, you just got to get rid of some of that glazing.
Yeah, I'm a member of the United Nations here, and the United Nations has recently published that they are no country in the world is anywhere near the goals that they've set
Oh, I know.
for their
Oh, I know.
energy conservation.
Yeah,
And that doesn't bode well for our future.
it does not. You're right.
so
But
The back is.
let's take one more question and then
Wrap it up.
then we'll do it offline.
have more offline conversation. Could you talk a little bit about how your firms have integrated these tools into your design process? By mandate, by training, top down, like you require this for the project team, or how are you doing this?
I think you probably integrated it more than we have yet. We did a presentation with AIA California, where we took 3 of our projects and actually ran them through CARE, and actually learned a lot. So I think it's not that hard. I was pretty impressed with how fast Laura and Allison did it.
But I would say a lot of times our clients come to us and they know they have an existing building or they have a site.
Right.
They don't have, we're not.
They don't have a building that needs to be torn down.
Tear it down.
Right.
And then we use it as a tool, as Larry say, we kind of we learn the metrics, we understand what difference it has made between, comparing we saved this building and this is how much carbon we saved. So that's kind of how we've been using it, because we're often not faced with those choices.
Right.
Um,
I mean, one thing that's great with the CARE tool, even if they're not looking at replacing it, is you can say, okay, by reusing a building, you're starting already ahead. You're basically, you should pat yourself on the back that you're not doing a new building. And they never were going to do a new building, but it's good to know that if they'd made that choice, they would have emitted hundreds and hundreds more tons of carbon to do that. So it's just a way of sort of encouraging people to continue to, because then they'll maybe make other choices, the low carbon choices, because, so I
it's an
don't,
awareness, it becomes more of an awareness.
right. I don't, you guys use
Yeah,
it quite a
in
lot.
our what I set up here, business as usual, good, better, best. We try to show this to a client on every project. And usually it's not so neutrally in climate terms, it's in terms that they care about. We have done a lot of K-12 work recently. When we do K-12 work, we say, we're building this building in 2025. It's going to be around like your old buildings for another 40 years. In those 40 years, your campus is going to experience unforeseen and difficult consequences of climate change. Your students are going to live in that, across that. These are the students going through your school in that era.
Right.
What can you do to help them better prepare to live in this world? One, you can build really resilient buildings, low energy, and you can build a building that shows the campus that another way is possible. That these projects that contribute to climate change, you have a role in reducing that because it affects the people that are going through the school and their future. And then we ask for an ad service, No, we try to build as much of this really as we can into the base, but eventually too, it's to do an LCA. We did one for a big student housing project. Recently, it took 4 days of, a staff person's time to do it. The stuff takes time to do well, to the extent that clients have, we share expectations, we can build it into the base fee. Other times we say this is really important. This analysis can drive your project the right direction. Okay. Otherwise we use a tool like Epic to say, okay, this is about where we're headed. We're going to really focus on this spec and this spec and go all electric and just do the rest by the skin of our teeth, because project timelines are really fast.
Right.
Is that helpful? I don't know.
All right, I'm gonna close it up here. Thank you all, panelists and guests. And I just want to remind you that if you want to continue the conversation or start others, we have our regular group that will be forming with our November meeting on the 28th. And please contact us at acote@aiaeastbay.org. Thanks again, Larry and Jack. Really great to see the work. Thank you.